Hello students and friends. Today in this video I'm going to introduce you to the concepts of proton NMR spectroscopy, which is an important topic for the students in their study of chemistry. And because to understand the NMR spectroscopy, you do require some basic concepts of physics. And because many students have not taken up physics along with their chemistry, they find it hard to comprehend the principle behind the working of the NMR spectrometer. So I decided to go into some basic concepts of physics, taking certain pages from the grade 10 physics to make you understand some basic idea about magnetism. And with this attempt, I think you will be able to grasp the basic principle of the spectroscopy and help you to interpret the spectra of the NMR in a more intelligent manner. So after all, what is spectroscopy? Spectroscopy refers to the technique in which we use radiation to study the structure of molecules. It sounds very strange, but it is true. And generally, we study the structure of the organic molecules because it is the organic molecules which present with the maximum difficulties related to their structure because their structures are very complex. So herein comes the role of physics, where the concepts of physics were applied to understand some complex phenomena related to chemistry. That's how the different branches of science work together. So proton NMR, that there are different kinds of NMR spectroscopy. One of that is proton NMR. Proton refers to the hydrogen nucleus, and it is based on the fact that just like electrons, nucleons like protons and neutrons also have a spin that may be clockwise or anti-clockwise. Now the students are already familiar with the spin of the electron. So same way, the protons and neutrons also have a spin which can be clockwise or anti-clockwise. Now to understand further concepts, we need to dive into some aspects of physics, and that's what I'm going to do in the following section. So I've taken here a diagram from the class 10 physics, and here it shows that there is a conductor through which a current is passing through a battery, and this is the direction of the current, and this is a metal conductor. So if you keep a compass needle in the neighborhood of this wire which is carrying a current, you see that there is a deflection in the compass needle, which means that the current is producing a magnetic field. So that's the idea I want you to understand, that current produces a magnetic field, right? Now this is a straight conductor, right? But it can be a coil carrying a current. So when you have a spinning proton or a nucleon, it's a charge which is moving in a circle. So it becomes something similar to a wire which is carrying a current. And it also produces a magnetic field around it and behaves like a tiny magnet having a north pole and a south pole. So this is again a diagram that I have taken from a physics book, that this is a coil of wire, conducting wire, and electricity is passing through it, and as the electricity flows through it, it creates a magnetic field around it, and this behaves less like a bar magnet having a north pole and a south pole. So this is what you have to understand. Now obviously, if the direction of the current is reversed, for example, if the direction of the current becomes this, like this, then the polarity will change. This will be the south pole and this will be the north pole. So now you have to understand that the spinning proton is like a coil of wire carrying current, and it produces a magnetic field. So the nucleon proton can have an anti-clockwise or a clockwise spin, but so long as there is no external magnetic field, these two protons have the same energy level. But when an external magnetic field is applied, then what happens is that the magnetic field of one proton may be aligned in the direction of the applied magnetic field, and the magnetic field of the other proton, because it is spinning in the opposite direction, may have its magnetic field aligned against the applied field, and that creates an energy difference between the two protons. And that's the important thing happening, that these two protons now have different energy levels. And now this is something with which you are familiar, that if you have two energy levels, then we can go from a lower energy level to a higher energy level if certain amount of radiation is absorbed by it. And the difference of energy level between these two lies in the radio wave range. That means uh, if radio waves are shining on this sample, then some amount of radio waves can be absorbed by the protons of the lower energy level, and they can flip to the higher energy level, and that creates a signal in the NMR instrument, and those signals we see in the spectrum. So that's the whole idea. And obviously this energy difference will depend upon the strength of the applied external field, and it also depends upon the proton under consideration. What is the proton environment? So as an example, I have taken a molecule of ethanol. So you can see that this proton is attached to oxygen, so this environment is different. These two hydrogens are attached to the carbon, which is attached to the oxygen. So these two the environment of these two hydrogens is different, and the environment of these three hydrogens is different. So there are three different environments for these protons, and therefore these protons will absorb three different radio waves from the NMR machine. But now here is a problem, that if we use different NMR machines, then they may be using different strengths of the magnetic fields, and therefore the same molecule may absorb different frequencies in different machines. So this problem is solved by taking a reference compound relative to which all frequencies are measured, and this reference compound is tetramethylsilane. And you can see the structure: silicon joined with 4 methyl groups, and that is the tetramethylsilane, and that is being used as the reference compound against which all the other signals are measured. You can be reminded of electrochemistry, where the standard electrode potential of the hydrogen electrode is taken as 0 volt, and all other electrode potentials are measured with reference to the standard hydrogen electrode. Same way, this is the reference point for our measurements. And obviously the question will arise in your mind, that why is this compound selected? Because here all the 4 methyl groups have the same environment, so this compound will give only one single signal in the NMR spectrum, and moreover the electrons around the protons are not pulled away towards silicon, because silicon is less electronegative than carbon, and therefore the nuclei is properly shielded by the electrons, and therefore it will always require a higher frequency for the transition to take place, whereas all other atoms will require lower frequencies. So there is a term used as chemical shift when we study the NMR spectrum, and chemical shift is defined as the frequency absorbed by the given proton minus the frequency absorbed by TMS divided by the frequency absorbed by TMS, and this whole thing multiplied by 10 raised to 6 to give you a proper value. Otherwise the value may be too small. So because it is a million, therefore the unit is called parts per million, or ppm. So the unit for chemical shift is ppm. And now the frequency or the chemical shift will depend upon the nature of the atom which is attached to the carbon. More electronegative the atom, greater is the chemical shift, because the electrons are drawn away and they can experience a stronger magnetic field, resulting in a greater chemical shift. So now let us just take as an example, what kind of spectrum would you get for the molecule of ethanol? And there is a table that you have to refer for chemical shifts, and you can identify the different environments of protons from this table, and you can see the chemical shifts. So as I told that there are three different environments for the protons. uh, all the three protons are similar, but they are different from these two. So there is one signal corresponding to this, and the chemical shift is around 1.1, which corresponds to this methyl group, so which is correct. Now this proton is next to oxygen. So when the proton is next to oxygen, we have these values here, which will be between 3.3 and 4.3. So we have this about 3.6 chemical shift, which represents these two protons. And finally this proton, which is an OH proton, so the OH proton has a signal somewhere about 1 to 5.5. So this is about 5.5. So this is also correct. So this way we can study the structure of organic molecules by observing their NMR spectra signals and comparing it with the chemical shift table. And this is a low resolution NMR, and there is also high resolution NMR, but we will discuss the high resolution NMR in another video. This was just to explain you the basic concepts involved in the study of the proton NMR spectrum, some part of physics which is needed to understand the magnetic fields and the energies associated with the magnetic fields and the spin, and hope you all understood this very well. And now in the further lectures you will be able to grasp the more complex ideas involved in the elucidation of molecular structures by studying their NMR spectra. Thanks a lot for watching. If you found this video useful, please like it and share it and subscribe to my channel. Thanks a lot for watching. See you again in the next video.